find the volume of the solid obtained by rotating the region enclosed by, we're going to take the same region, y equals x and y equals x squared, and we're going to rotate about the line x equals -1. So same picture of our region, we're just rotating around a different line now. So I know what this region looks like. If you didn't, you would have to find the intersection points and all that stuff. But I already know what the region looks like. Goes through 0, 0, 1, 1. I have my line. And then my parabola. Okay. And now I'm rotating about x equals -1. So, -1. So this is where I'm rotating about. Maybe we'll do that in red. So I'm still looking at the same region as last time between these two, but now I'm rotating this way. Remember, we take our strips perpendicular, so my line, my rotation line is vertical, so my strip should be horizontal now. Okay. All right. When I rotate this around, what am I going to get? A disc or a washer? Rotate this around. A washer. There's going to be a hole in the middle. Right? So again, I have a little r and a big R. Now, my strips are horizontal, which means I have a left and a right. So we're going to integrate in terms of y. Make sure we don't forget, integrate in terms of y. So I have a little r and a big R I got to find again. The little r is the one that's closest to my rotation line. The one that's closest looks like the line is closer than the parabola. Okay, so I want to find little r. That's this distance here. This is little r. So what I'm going to do is I'm going to think of this instead as being made up of this distance, which is 1. This distance here is 1 plus this distance right here, and that distance, this little distance here, is x because it's a horizontal across, but that's the line y equals x and x is equal to y. So it looks like to get that blue distance, I need to add up these two little red distances to get the blue. Right? I add up this 1, I add up this x, but x is equal to y for this line. So it looks like my little r is going to be 1 plus x, or 1 plus y. Sorry, we're doing it in terms of y. Add up the two little red pieces to get up the total blue piece. Now let's do big R. Big R.
Did you also do 2 minus R? Never mind.
Okay. So big R, the function that's furthest away, is my parabola. So I still have this red distance of 1 here. And then this other problem is I don't have enough colors to distinguish all of this for you. But this extra distance here, I'll do that there. Do it here. This extra distance here is going to be given by my equation, which was y equals x squared. So it's going to be x, what was it? My equation for this one was y equals x squared, but we need to solve for x. Square root, right? X equals the square root of y. So this is square root of y. And so this will be 1 plus the square root of y. If I do too much math in my head, I don't get it quite right. So I know there are lots of colors going on. I mean, if you need to do this for yourself on your paper, you can color code things, or if you need to make 2 separate pictures, one to figure out little r, one to figure out big R, you can do that too. Okay, so there's our little r and our big R. Are we going across?
-1?
No, this is our rotation line. So all I'm doing, little r represents the distance from our these radius. They're the distance from our rotation line to our curve. See what? You're going from your curve to -1. We're not going across, no. Because, I mean, when you rotate, you are going across, but that would give you your whole diameter for your disc or your washer. We only need the radius, so we only need half. So I just got to go from my curve to this. Did that help? You're rotating around, right? Okay. Here, I think I can help. You're rotating around, and we said you get a washer, right? So imagine this point in the middle is my rotation line, okay? This point is the rotation line. So when I find, let's see, I used blue. This is little r, and then green was my big R. You're just going on one side of your rotation line to get the radius, right? Because it's half of your total diameter. So you really only need to the right of -1. You don't have to go to the left of -1.
The overall solid that we're figuring out the volume for covers.
It does go all the way around, yes, yes. It does go all the way around. You are right. Yes, to figure out, because we're only looking for radius, I don't have to worry about the other side of my solid, yes. Okay. We figured out little r, we figured out big R, we're ready to use our formula. So to find the volume, we are going to integrate. Remember, we're doing in terms of y now. So pi, and then it'll be a big R, 1 plus the square root of y squared, minus pi little r, 1 plus y squared, dy. And now what do I put on my bounds for my integral? It's in terms of y. What were my range of y values in my region?
0 to 1.
0 to 1. So it just happens to stay the same here, but be aware it might change 0 to 1. Okay. And then the rest is just computation after that. computing all this fun stuff. So let's see. Again, I'm going to factor out a pi because it appears in all my terms. The integral from 0 to 1. And then you need to FOIL two things. You need to FOIL this and FOIL this. So it looks like I get 1 plus 2 square roots of y plus y for the first one, minus 1 plus 2y plus y squared for the second one. And then you'll get pi. Combine your like terms, you'll get 2 square roots of y minus y squared. And at this point, you just do reverse power rule for all of these. So you add 1 to the power. What do you get when you integrate y to the 1/2? Add 1, 3/2 over 3/2 minus y squared over 2 minus y cubed over 3 so it looks like 4/3 minus 1/2 minus 1/3. When I plug in 0, I get 0 everywhere. And if you get a common denominator, you should get pi over 2 for this.